Okay, I will review our tutorial questions. Let's take a look at the question number 1. This is our current soil geologic profile. Determine the primary consolidation if CS 0.05 for the followings. Okay. Pre-consolidations were given. This pre-consolidation is for sand, is for second layer sand, is for clay. Which one? Clay. Only for clay. So consolidation settlements take place where? Sand, the second layer sand, the sorry, this is a clay, only clay layer. So in this case, we have 3 scenarios. NC clay, okay? OC clay, another OC clay. First of all, first NC clay, we are able to calculate from here to here. So H over 1 plus our initial void ratio and CC. Log initial ratio of initial effective stress and final effective stress. In this case, initial effective stress mostly identical to pre-consolidation pressure. That's why it is NC clay. What is the OC clay? My pre-consolidation pressure is the maximum. My initial one is less than my pre-consolidation pressures. My final effective stress also smaller than pre-consolidation pressures. So I don't have any more of initial margin curve. So I only take these volume changes. H over 1 plus initial void ratio, CR, and log initial effective stress and final effective stress. Both of these stress still smaller than pre-consolidation pressures. And high, keep on increasing. Your final effective stress now exceed pre-consolidation pressures. So I want to calculate from here to here before pre-consolidation pressures and from here to here after pre-consolidation pressures. For this yellow parts, this CR. This green part, these terms. In the here, my maximum stress, effective stress is the pre-consolidation pressure, right? And then for the green area, virgin compression curve, your initial effective stress is your pre-consolidation pressures. Here is the maximum, here is the initial. Okay? You have these 3 different scenarios in your head. Then you need to identify whether display force on NC, OC. How do you know? Hi, pro, understand. How do you know? Compare your effective stress with your pre-consolidation pressures. That's why we need to calculate effective stress on the clay layer. Which point? Here, 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 here? Where? Mostly center. Mostly center. So, let's calculate effective stress. Water table is here. So, this descent layer is total density. Yes, it is correct. Technically, descent layer is not that dry conditions because to capillary rise, water comes up a bit, comes out a bit. That's why we indicate that total density. So 5 meter times 18.7 plus 5 times 19.7 minus out 9.81 because effective stress is the ignore water effect. Descent layers unit weight is a gamma saturated soil unit weight minus out water unit weight plus only 1 meter times gamma prime. Wow, already given. This is your clay layers effective stress at point center. We call it average effective stress. This one is same as this effective stress greater than this. Let's see what happened. Your initial vertical effective stress 5 meter times 18.7 plus 5 times gamma prime plus 1 meter times gamma prime. Okay. The clay layer effective stress is now 150. Wow. 150. Question 1, number 1 question is NC condition. CC given. Sorry. Here. CC is here. Then your height 2 meter. Your clay layer total over 1 plus your initial void ratio 1.1. Your current initial effective stress is 100, actually 150.85. I missed the 2. It's okay. And then what is your final one? here. 100.85 plus additional 50 kilopascal. Now, the pre-consolidation pressure equals to your initial effective stress. Second one, your pre-consolidation pressure is 175. 175 over current effective stress is 1.16. OCR is greater than 1 over consolidated crane. OC case. My initial is 150. And then currently my pre-consolidation pressure is the 175. And on top of this, I added up 50, which is a 200 something. This is OC clay, but second OC, right? So we use the such long equations. First part is the yellow, second part is the green. So that's why we need to know CR. CR is equals to CS. Always CR equals to CS. Decompression and swelling, same. This is our assumptions. 0.05. 2 meter clay. 1 plus initial void ratio. And your initial one is a 150. And maximum your effective stress is pre-consolidation pressures plus your CC 1 plus 1.2 2 meter clay layer and your initial effective stress is your pre-consolidation pressures and initial plus additional one. But now your pre-consolidation pressure 250. Wow, so big, right? Your initial effective stress is 150. Your additional surcharge is 50. Your maximum effective stress 200, around 200. But your pre-consolidation pressure 250. Number 3 question is only yellow area. So we are going to use CR, CC, same, 0.05, 0.01, 0.5, 2 meter, 1 plus initial void ratio, log your initial effective stress plus final effective stress. Only 6 mm because your pressure history is quite high. But in the test, your additional load, applied load quite small. So your settlement quite small. You're strong enough. But when you have normal clay, normally consolidated clay, your settlement is quite significant. And another OC is the middle way. The question number 2, also same. First case is a normally consolidated situations. Second one is the pre-consolidation pressure is the 190. And third question is the 170. Your memory of pressure is different, but your clay layer current effective stress can be compared with these two pressures and then calculate find out the equation you are going to use. In the final exam, this kind of calculation will come up. Take a seat and then face this question number 2. Consider as the final exam questions. And then try and find out where you were stuck. And then how can I address that point? How do I break through that steps? I mentioned that one of the final exam questions. You are able to calculate exact final product of consolidation. Okay, second question. So why? The question was quite long. A 5-meter depth of sand overrides a 6-meter layer of clay. Okay. Water tables being at the ground surface. Okay. Typical situations. The permeability of the clay is very low. Makes sense. The saturated unit weight of the sand is a 19, and then clay is a 20. Okay. A 4-meter depth of fill material of unit weight 20 is placed on the surface of the over extensive areas. Oh, here, right? How do you know? 4-meter times 20, it means 80 kilopascal, right? This field, additional surcharge is the 80 kilopascal. Please determine the effective stress at the center of clay layer immediately after the fill has been placed. Oh, complex. Okay, immediately after, okay. And then assuming these two take place rapidly and many years after the fill layer has been placed. Wow. Okay. In summary, we need to calculate effective stress right after and many years after. Simple. I'm gonna show you my solution. I take the middle of the clay. Nineteen times 5, 20 times 3, 155. I prove gamma prime. You forgot gamma prime. Why suddenly 19, which is the saturate, right? Wait. I also calculate water. 9.81 times 5. 9.81 times 3, total 8. I will minus out, which means that 19 minus 9.81 times 5 plus 20 minus 9.81 times 3. Same situations. Same process. This process exactly same as this. Okay? So before filling, my effective stress is 76.5. And then I added up 80. My current total stress is 80. Right after this placement of the fill layer, the pour water will support this additional 80. This is the makes sense, right? So immediately after this additional surcharge supported by excess water pressures. So your effective stress remain constant, unchanged. As time passes, the water in clay squeeze out here, here, for example, and then excess port pressure decrease. This excess port pressure, the amount is exactly same as the what you apply, 80 kilopascal. And then these port pressures gradually decrease. And this total stress becomes effective stress. So after after some time passes, your soil's effective stress plus your surcharge load act as a effective stress. So your final effective stress is 156.5. So many years after, the initial total particle stress is 80. And then finally, this becomes effective stress because excess water pressure already has gone. So before immediate, almost same, and then after some years, your source effective stress increase. This, the question number 3, help you to have a clear understanding of the consolidation process.